بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. Today inshallah we are going to talk about the thermochemistry lesson 2 thermochemistry. First secondary. We are going to talk about the thing that's called the heat content. Firstly, any matter store energy. This energy are found as a stored energy between the atoms, maybe inside molecules, and the energy stored between the molecules and each other. Firstly, the energy stored inside the atom, it represents the energy of electrons in energy level. When you have an electrons, these electrons in the one of energy levels at the distance from the nucleus start to attract these electrons, and by centripetal force or centrifugal force, these electrons not fall inside the nucleus. So, as it have a distance from the nucleus, it have a potential energy, and else its move rotates around the nucleus in elliptical path. It have a kinetic energy. So the energy stored inside the atom, it represents the energy of electrons when it rotates around the nucleus. Potential energy, as it has a potential or position from the nucleus, kinetic energy due to its movement. If we're talking about the energy inside the molecules, we are going to talk about the bonds. And we have different forms of the bonds between the molecules and each other inside the molecules, like the ionic bond and the covalent bond. The bonds or the energy stored between the molecules and each other. Each molecule attached with another molecule in its crystals by the force, it is called the potential energy due to the position of the molecules beside the another molecules. This is called the van der Waal. This force depends on the positions between the molecules and each other. This is potential force between the molecule and each other. Sometimes we will find for this water molecule and another water molecule, we will find this hydrogen atom stand between two atoms have higher electron negativity. This electron negativity is 3.5 and this electron negativity is 3.5, and we will find the hydrogen in this case stand between the two atoms which have the higher electron negativity. Attached with this atom by single covalent and with another atom in the another compound by hydrogen bond. Hydrogen bond represents one of the bonds between the molecules and each other. It's increase the boiling point of the water and decrease the freezing point of the water. The total of stored energies inside the substance called heat content. What's meant by the heat content is the summation of the stored energy inside these substances. So as we said before, we'll find that the substances are differ from each other in the number of the atom, the bonds between the atoms, and the total of this amount of these energies are it's called the internal energy. Internal energy. استنى كده اهو. Okay, it's called the internal energy. Bismillah. It's called the internal energy. So, the internal energy may be stored in the chemical energy inside the atom due to the movement of electrons and the kinetic energy of electrons. May be stored energy in the molecules, the bonds between the molecule, covalent or ionic. Intermolecular forces, this intermolecular force is the attraction between the molecule and each other, van der Waals force, and the hydrogen bonds between the molecules and each other. The total of the stored energy, it's called the heat content. What's meant by the heat content or molar enthalpy? The sum of the stored energy in the 1 mole of the substance. So the heat content or molar enthalpy, the sum of the stored energy in 1 mole of the substance. The heat content or heat change, we are going to talk about the heat change. Heat change. Heat change, it means the difference, heat, delta H, or heat change. It means that delta H equal H of product subtract H of the reactant. It means the difference in heat content between reactant and product. As we said before, molar enthalpy or standard heat content mean heat change for 1 mole of the substance. In this case, delta H equal Q over N. Q represents the amount of the heat, amount or the quantity of the heat. N represents the number of moles. Okay? Delta H represents the heat in the change or the molar enthalpy, and it measured by the kilojoule. Let's talk about an examples. For an examples, we need to calculate the molar heat enthalpy or delta H. Delta H equal Q over N, quantity of the heat number of moles. But for like these examples, when we find the heat or the quantity of the heat, in this example it will be by negative sign. Why? Because it represents the burning process. And in the burning process, it represents the exothermic reaction. Exothermic. In case of the exothermic, the value it will be by negative sign. Okay, firstly, let's talking about planning for this problem. We must firstly calculate the quantity of the heat Q and the number of moles. Okay, let's put the graph or the draw to represent the problem. So firstly, when we burn the amount of the benzene inside the calorimeters, constant pressure calorimeters, we will find the quantity of the heat is released. We can determine the quantity of the heat from the heat capacity C times delta T. Heat capacity for this reaction, it will be 551 joule times the difference in temperature. We will find the temperature is differ by 8.60. So we will find the amount of the quantity of the heat 4.74 kilojoule. Number 2, return to calculate the number of moles. The number of moles for the benzene, the mass of the substance over the molar mass. Mass of the substance 0.113 over the molar mass of the benzene, 6 carbon atom, multiply its molar mass 12 plus 6 multiply 1. So return to calculator to calculate it. So the answer, it will be 1.44 times 10 power negative 3. 4 says, firstly, we are going to talk about the delta H. Delta H, according to the equations, we will find the 2 moles for the benzene. And it is only for the 1 mole, so it will be negative, firstly, as it's exothermic. And the 2 moles from the benzene, multiply the quantity of the Q, 4.74, divided number of moles from equation. Since we need the molar enthalpy for 1 mole only, divided what? Divided 1 point, number of moles, 1.44 times 10 power negative 3. Calculate the value, equal negative 6.55. If we illustrate it by the graph, this figure represents the quantity of the heat that's released, or the molar heat enthalpy, quantity of the heat, or the molar enthalpy of 2 moles from the benzene. Okay, let's complete. We are going to talk about the heat content. Now, the scientists said that the heat content for any element is equal to 0. The quantity of the heated or absorbed or released, delta Q, sometimes in the case of the burning, it will be by the negative value. Now we are going to talk about the equation and type of the equations. Type of the thermochemical equations. Bismillah. Types of reactions according to heat change. When having the 2 types, it's called the exothermic and endothermic. The general formula for this, it will be the reactant giving to us the product plus heat, and the value of the delta H equal negative value. The general law for the heat content said that delta H equal H of the product subtract H of the reactant. What's make the delta H value, it will be by the negative value. It means that H of the product less than H of the reactant. For endothermic, we'll find the reactant plus heat giving to us the product, and value the delta H equal the positive value. What's making the delta H positive value? It means that the H of the product greater than H of the reactant. If we represent it graphically, we are going to present it graphically. So for the reaction like the reaction between thermal decomposition of the magnesium carbonate, we'll find the reactant, it starts from the 0. When it reaches the 117, I think it's the not correct way to find the reactions. This is the endothermic reactions, and this is the exothermic reactions. So firstly, start by the exothermic reactions. Reactant heat content equals 0. After the end of the reaction, we will find the water is formed. The value of the delta H is the difference between the reactant and the product, equal negative 285.8 kilojoule per mole. And for the endothermic reactions, we will find the reaction of the thermal decomposition of the magnesium carbonate, it giving to us magnesium oxide and the carbon dioxide gas. The difference, it represented the difference between the reactant and the product. It will be 117.3 kilojoule. Let's take another examples. Another examples, we will find the burning of the carbon dioxide gas, C plus O2, by the effect of the heat giving to us CO2. The value of the delta H equal negative 243.7 kilojoule per mole. If we represent it graphically, so we will put delta H in this axis and the progress of the reaction progress. We'll find, we'll start from the carbon plus oxygen, heat content equals 0, till we reach the product carbon dioxide gas. Delta H equal negative 234.7. Delta H in this case equal the difference between the product subtracted the reactant. The product negative 234.7 subtracted the reactant equals 0, so it will be delta HK negative 234 kilojoule 0.7 kilojoule per mole. And for the endothermic reaction between the hydrogen and iodine giving to us hydrogen iodide, delta H value equal positive 51.9 kilojoule per mole. So we'll find delta H starting from the 0 for the reactant, so it will be delta H progress of reaction hydrogen plus iodine it giving to us 51.9 kilojoule per mole. The product, it will be 2HI. In this case, the difference between the reactant and the product, it will be positive 51.9 kilojoule per mole. So in this case, we will find for the endothermic delta H value, it will be by positive, exothermic, it will be by negative. Let's talk about the bond energy. If we're talking about the heat content and the bond of energy, for formation of any compound, we can have two forms of energies, or the two forms of the bond energy. Firstly, for the start of the reaction, we have a thing is called bond breaking, and it is represented the endothermic reaction since it absorbed it. يبقى firstly bond breaking, absorbed energy to break bond. Then after the formation of the bonds, we will find the heat are released, forming bond. After forming the bond, this type, since it's absorbed, so it will be endothermic by positive value. Then after the formation of the bond, we will find the heat released, mean that the heat released, so it will be exothermic delta H, or it will be by the negative value. So what's meant by the bond energy? Bond energy, it means that the amount of the energy absorbed to break the bond or released when the bond is formed of 1 mole of the substance. Type. Given an examples, we are going to talk about the burning process for the firstly, we will put the rule delta H in this case equal bond breaking plus bond making. And the value of the bond making must be by the negative sign. If we put it the positive, we must put the negative sign. Firstly, calculate the heat content or the heat of the following reaction. Determine the reaction is exothermic or endothermic. If the total value of the reaction by negative, it will be exo. If the total value by positive, it will be endo. Firstly, when having a methane, the value and the 2 oxygen atom balance the equation, in this case CO2 plus 2H2O. Firstly, we're looking to the bonds between the carbon and oxygen, 745 O and H, it will 467, CH 413, OO it will be 498. Firstly, we will write the structure formula of the compound. So we have a methane gas, 4 bonds, and the 2 molecules of oxygen, O double bond O, O double bond O, and carbon dioxide, 2 double bonds between the carbon and oxygen, and the water we have OH, 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 OH. Firstly, to determine the bond breaking. Bond breaking represents in this case 4 bonds from the type of CH, 1, 2, 3, and 4. 4 bonds from the CH, so it will be 4 multiply 413 plus 2 bonds from the type O double bond O, so plus 2 multiply 498, so the total value it will be kilojoule per mole. So the value it will be 2648. This is bond breaking. Bond making. As we said before making anything, we'll put the negative sign. Then we form the 2 bonds from the type of the CO, so it will 2 multiply C double bond O. So it will be the negative 2. CO it for 745 plus 4 bonds from the type of OH, 1, 2, 3, and 4. 4 multiply OH, so plus 4 multiply OH, it will 467. Calculate it. So we'll find the value, it will be negative 3366. According to this rule, delta H equal bond breaking 2648 plus bond making negative 3366. So that the total value it will be by kilojoule per mole. Calculated. So it will be negative 718. The total heat energy, our total heat content by negative sign. So the reaction in this case, it will be exothermic as delta H equal negative sign. As we said, we represent all of these reactions by thermochemical equation. What's meant by the thermochemical equation? It is a type of equations, balanced equation طبعا. Type of balanced equation represent reactant, product, reaction conditions, and heat change. heat exchange. So we must, in this case, we set delta H equal negative 718 kilojoule per mole. It's our topic today. Inshallah, see you soon in next time. Goodbye.